Now let's talk about the domain of the function. Okay, so as we were just showing up here, I might start out with an input, right? The x that I'm trying to evaluate it at. So I plug it into my machine and I evaluate my inside function, in this case g. I evaluate g at x, okay? So I get some answer, don't I? I get some answer here, and that's the answer that I'm going to plug into the second part of my function machine. So I'm evaluating the function f at my new answer, and I get a final answer here. Then that's kind of the process that we're going through. And we want to keep that in mind as we talk about the domain of a function. Because really, the domain of the inside function and the domain of my answer are related. Okay, so let's look at this example down here. Example 2. In this example, I'm starting out with my two functions. I have f of x and I have g of x. And I'm only going to work part A in this case. Okay, so I'm doing A. And I want to know, first of all, I want to be able to compose f composed with g, and I want to be able to find the domain. As I work through this process of finding the domain of the composite function, I will end up finding what the composite function is, and you'll see that in just a second. So we're going to start off here with our two functions. The first thing that I need to be able to do when I do this is I want to be able to find the domain of the inside function. Well, what inside function am I talking about? I'm talking about, since I'm working letter A says f composed with g. Well, what does that mean? That means f of g of x. So in step number 1, I want to find out what the domain is of g of x. So the domain of g of x is going to be, remember when we talked about domains several chapters back, when I'm talking about the domain of a function, let me write this down over here, the domain of a function. I'm really interested in, I want to look for fractions, so I want to look for a denominator. And I want to look for a negative under a radical. So, coming over here, I'm looking at g of x. Does g of x have a denominator to be even concerned with? Well, no, it doesn't. Okay, so I don't have to worry about that part. Does g of x have a radical? No, it doesn't. If neither of those two options apply, then the domain of g of x would be all real numbers. Okay, all real numbers. That's step number 1. Now step number 2 says, I need you to come in here and I want you to now construct the composition of our function. Remember, I need to now construct f of g of x. And then I want to find the new domain. So in this case, I'm going to take f of g of x, and let me just write this down here. F of x is originally x squared plus 3x minus 1, and g of x is 2x plus 3. Okay, so when I evaluate the function f of x for 2x plus 3, then I'm essentially going to go in and replace each one of these x's with 2x plus 3. So I have this first x squared plus 3 times something minus 1. Now remember that what I'm replacing x with is actually g of x. So I'm going to go in and I'm going to replace each one of these with a 2x plus 3. And this is just the algebra of what we're doing. Now, when I am squaring this binomial here, I can actually square the first term. When I square my first term, 2x quantity squared becomes 4x squared. I can double the product, which means that I'm going to multiply 2x times 3, and I'm going to multiply that times 2. So 2x times 3 is 6, times 2 is 12. So I get plus 12x. And then I'm going to square the last. So 3 squared would be 9. So I get square the first, double the product, square the last. And that's a shortcut for being able to FOIL this special product. If you need to just go through and FOIL it, it's not a big deal. Now I'm going to distribute this 3, and I get 6x plus 9 minus 1. Now let's clean this up just a little bit. I end up with 4x squared plus 18x plus 17 once I combine my like terms. Now this right here, this that I just found, is the construction of f composed g. That's my composition function. Now what would the domain be of this composed function? Well, remember, I'm interested in fractions and radicals. Do I have a fraction in this composition function? No. Do I have a radical sign in here? No. So the domain of f composed g is all real numbers. But I'm not done yet. I'm almost done. The last thing I want to be able to do is I need to combine both my domains. I might have had a restriction come up here in this first domain that I would have to include in the second domain. But since I don't, since the domain of both of these, and let me underline this, the domain of this one is all real numbers. The domain of g of x is all real numbers. So the domain of my final function, so the combined domain, is all real numbers. So that would be the final answer.